Greetings. Today we have a plastic briefcase or equipment case or whatever. And what this is, it's the MK-80Z, the Fox, by E&L Instruments. And it is a Z80 microprocessor trainer. It looked really interesting. I found it on eBay. This one had some problems though, so I got a good deal on it. So let's go ahead and open it up and see what's in here. Okay, how does it work? To remove lid, open 90 degrees and push here. Oh. And here it is. It's a trainer. The interesting part is it's a Z80 trainer, but this is early 1990s vintage. So I guess at that time there still was a demand for 8-bit microprocessor trainers. So this one came in, and the problem with it is you give it 5 volts and the display is supposed to light up. However, it does light up. I don't even know if I can show it to you. Well, yeah, see, you can see it here. It's really, really dim. So really what it does, let me get it out of the glare, scrolls in ready and then sits there. Now obviously the processor's running. You can hit buttons, it beeps telling you that it's responding. So the right side of this, which has the Z80 on it, has an EEPROM, RAM, empty sockets for future expansion, and then on the left side it has a breadboard, logic switches and that good stuff. Funny thing is, the Z80 CPU is actually sitting over here. I guess you could put it either in here or in here, or you could put one in each socket and then it'll run twice as fast. I don't know. I do have documentation for it, which I have just briefly skimmed over. But first, we need to fix this display. I mean, at this angle it seems perfectly readable, but you know how the camera overemphasizes things that are lit, and it's just too dim. I mean, you can see that once I put it down, even without the reflection, you can see that it's still on, but it's pretty much useless. So let's have a closer look at the display. It has this red diffuser on it that I guess is supposed to make it more readable. But if we take this off, what we find is, this is, I guess this wasn't, the displays went weak, and this, I guess, is an attempt to make it more readable. There's a piece of window tint. It's a curved piece. Somebody just dropped it in here. They didn't even use adhesive or anything, which probably made things worse. Or maybe not, because now you can't read it at all. And at least with this on top, yeah, I guess it makes it more readable. But if we look at this closely, see all of this white stuff over here? And there's no residue around it, so this is not as if something got poured on it, but I think the displays themselves have gone bad. So if we put the diffuser back on without the window tint, it makes a huge difference, but it's still not good enough, not nearly good enough. Now, if we logically look at the problem, I mean, it's working, it's scrolling in. Let's see. If I reset it, oh, I can't see it. And obviously the processor's running all of the digits. You still can't see anything. Oh, there was a position there where you could kind of see it. Anyway, so the assumption there is, without putting a scope on it or anything, is an 8255 parallel interface adapter over here, and that basically feeds medium current drivers here, here, and here, and those scan the display. And they're obviously working. I mean, there's a very slight chance that the drivers are bad and they're not letting enough current through, but that is relatively unlikely. I think the next thing to do here is to actually start removing at least one of these guys and having a look at it, because they definitely do look. There's some sort of damage here. You can see on this one, something's leaked. And again, there's no residue around it, so whatever leakage was caused, or whatever this stuff is, came from the display itself. So let me warm up the iron and see if I can get one of those displays out without destroying the PCB. Alright, I desoldered one of them very carefully. Fortunately, this is a pretty high quality board with gold-plated pads, and nothing came off, so pad-wise that is. And it actually came out relatively easily. Look at the back. It's almost like something leaked in there. What I think happened was I don't know what they put in these. There's a big bubble over here. I guess they filled them up with epoxy or something. Whatever this material here is, glue, epoxy. And it's obviously not very clear anymore with whatever's melted here, or just disintegrated, and that may have also covered part of the front, which is probably what's making it weak like that. I don't know. I could probably sit here and guess at this all night long, but the bottom line is yeah, these are defective. They are uniformly weak, so whatever happened to this happened to all of them. Bad batch of 7-segment displays. So we need to take all of them out. But what's even more important is we need to find a replacement for these. I checked all of the places that I usually buy parts from. There are a bunch of surplus places, and no luck on those. Then I went, to the commercial, well, not commercial, but the ones that sell current parts, Mauser, DigiKey, Newark, few others. Nobody had these. I mean, it's a standard. It turns out it's a standard part because I can find them when I do a general Google search. They appear on like Ali International and places like that. But the problem with Ali is, it takes like 3 years to get to the United States from China, and I didn't really want to wait that long. Then, of course, I hit eBay. eBay had something close. It wasn't exactly the right thing. but they were ridiculously priced. I mean, I'm talking like $6-7 a piece plus $4 shipping. And so that was out. So then I went to where I should have gone in the first place, and you guessed it. I went to Amazon. Amazon had these. I guess they're like $6 or $7 for 10 of them. And here they are. It is, I mean, they're exact matches. Problem is, even though they put up data sheets on Amazon or copy them and put them in the ad copy, is the data is wrong. It's not always the correct data, and some of them put up links to data sheets, but the data sheets are scanned at like, 10 dpi or something, and you can't really read the measurements correctly on them. So, for the huge amount of money I was committing to, I figured, hey, let's take a risk and just get some so we can get this guy fixed. And the digits are slightly bigger on this one, on the replacement, which is a good thing, but the case dimensions match, and obviously the pins match. And just for comparison, here's what a fresh one looks from behind, and here's what a rotted one looks from behind. So I think we've definitely found the problem here. So now comes the pleasant work of removing the remaining 5 and then putting in the new ones. I won't bore you with the details, but I'm doing this very carefully because I do not want to damage the board, even though it is of high quality. But, using a desoldering gun to get the majority of the solder out, and then using braid, very thin braid actually, to suck the rest of the solder out of it. And I'm going to take my time, and we'll see you back when everything's out of the board. Took me about half an hour to get them all out cleanly. None of them resisted greatly, and all of the pads are alive on both sides. Now, every single one of these I pulled has that white stuff, is showing that damage on the back. So did it melt? I don't know. If you have any idea what happened to these, let me know, because obviously they still work, but with greatly reduced brightness. And the seller on eBay had like 2 or 3 of them with the same problem. So if you're one of the ones who bought one of these, here's your solution. Some more extensive, some less extensive. This is probably the cleanest one, but they all show the same dimness. So what we're going to do now is insert the new ones, solder them in place, and see if that fixes the problem. But before that, a very important thing to do, which I didn't, was it's probably a good time to take out the EEPROM and to read it. Make a backup copy of it. I may want to disassemble the code in it someday and have a look at it, but if this EEPROM dies, it's probably going to be difficult to find a copy of this out in the wild. So yeah, that's the next thing I need to do before putting in the new displays. Alright, the deed is done. put everything in, put the diffuser in, left this out, and here we go. Very clearly readable. Shows up a little pale, but it is deep red. And we hit a few buttons here. For instance, the register. So what's in BC? Shows it to you. Put in an address. If the dots light up, that means that's editable. So and then you press data. Let's see, will it let us change it? Nope, it won't. Now, we're going to have a look at the address map and everything. Maybe that there's no, I don't know where the RAM is in here. But I do have a manual and I do have schematics for it. So let's put this guy back into his case and then see what we can do with him. It's reattached to the bottom of the case, and I guess now it's time to check it out and see what this thing's capable of. The only thing I noticed is there's a bunch of tantalum caps on here, and as you may or may not know, they don't age well. Here, and the problem is that when they go bad, they short. So I should probably be thinking about replacing those, but that's for another time. Okay, let's now see if we can actually enter a program and run it in here. We'll find something very short, but we'll go through the motions or the actual procedure of entering a program in here and then executing it to see if it works. Now, earlier in this video I stated something that isn't quite true. I said that this device came out in the early 1990s, and that was sounded a bit curious to me too, because why would they come out with a CPU trainer in the early 1990s? An 8-bit CPU would be the last thing people wanted to learn, but I finally did the obvious and checked date codes, and the date codes are mostly 1982 and 83. So this thing came out in the early 80s, and I think that time frame makes a lot more sense. I got a copy of the manual, finally. And it has some example programs, but they mostly deal with I/O and with the special circuitry on here, which is kind of beyond the scope of this video. I just want to enter a short program, go through the procedure of entering the program, and then see if it actually runs. So this is a short program, 4 bytes in length, that sounds a 2 kilohertz tone for a specified amount of time. Now, when you hit keys on this, it generates a 1 kilohertz tone. So at least the tone it generates should be twice as high in frequency as the key does. So the key, okay, so that is 1 kilohertz. And what we're going to do now is enter a program that plays a 2 kilohertz tone for as long as we want. So off we go. To enter a program, we press address, and it's already set to 1800 hex, which is the user RAM area. Note the decimal points, which indicate you can now type in a new address if you want. But what we want is to enter data. First byte of data is CD, which is a Z80 call subroutine instruction. We go to the next memory location and we enter the low address of the subroutine, which is E2, and then the high address, which is 05. So 5E2, after looking in the manual, is the monitor ROM sits at 0 or thereabouts. So we are calling a monitor ROM routine that plays a 2 kilohertz tone. And the final instruction to enter is 76. Kind of brute force. When the program's over, halt the whole system. Halt and catch on fire. But that's not very elegant. I would imagine they go back to the monitor and instead of the thing locking up on you, but that's the way it is. So the next thing we got to do is enter the length of the tone, of the 2 kilohertz tone, and the way we do that is we go to a register, the HL register on the Z80, and it's telling us that right now the HL register contains an 03 in H, an FF in L. We press data, and then this is kind of a shortcut. When you first, after pressing data, if you hit a 0, it zeroes out the entire L register, but we leave L at 0. We go to H, the upper part of the HL register, and looking at the little table, we want to hear a that's too long. A 1 second 200 kilohertz tone, and in order to do that, we need to set H to 808. Okay. Next, we want to execute the program, and the way we do that is, let's see. Let's check the PC. We can now double check that we entered everything correctly using the next and previous keys. So CD, E2, 05, and 76. Let's put the PC back to the beginning of the program. And now all we got to do is press go. Okay. So there was a 1 second playback of a 2 kilohertz tone. And note that the red light came on, and that is a halt light telling us that the processor is halted and nothing else is happening. Let's see if we can, if it actually maintains that in memory. If we press reset, the PC is still at 1800, so this should still work. And there you have it. Now we can alter HL to give us different lengths, and just for grins, let's see if that works too. So we go back to register, HL, data, next, and if we change the 8 to a 4, we should get a half-second beep. So let's make a 4 in here. Make sure the PC is at the beginning, and okay, that was exactly half a second. It works. There are many more fun experiments in there, but they all get more involved, as I mentioned before. We have inputs, we have outputs, we have all sorts of good stuff, but you know, the really nice one is this has tape I/O up here. You can actually write your program out to tape. So I am sorely tempted not to do that, because my My only bad memories of the early computing days were the cassette players. But, you know, I guess you could record this to a digital device and then play it back and, you know, save yourself. I mean, for a 4-instruction program, it's not a big deal. But I think once you get into the 20s and 30s and 40 instruction area, it would probably be a good idea to test this with your phone or whatever digital recorder you use to see if you could actually save the programs. You can give the programs a 1-character file name, so I guess you can have a whole bunch of them in an audio file, and when you load something, you tell it to load file F. It'll go on your tape and read all of that in till it finds file F and load that. I know it sounds like a lot of fun, but again, I think we've shown that this thing actually works and that you can actually read the display on it. Yeah, it would have been nice if they had an example program that just counted up on the display, but they don't. And maybe if there's overwhelming demand, I'll actually write one and put it up there, but I don't think so. So I hope you enjoyed this. Thanks for watching. Please like, subscribe, and let me know what you think about this thing. And we'll see you soon.